Right, this is a worked example for, well, mechanics has got a little bit of forces in it, a little bit of kinematics in it. Quite a nice little question, really. Here we go. A particle P of mass 0.4 kilograms moves under the action of a single constant force of F newtons. The acceleration of P is 6I plus 8J meters per second. Find the angle between the acceleration and I. So I is the horizontal direction, J is the vertical direction. That's the standard convention with vectors. So we've got this force acting in this direction. An arrow on the end there, I guess. So what it's asking is what's this angle theta between the force and the horizontal. Okay, well, since it's 6, 8, it's 6 along, 8 up. That's what we're meaning by the vectors. So this angle is going to be the inverse tangent of 8 over 6. In other words, tan theta here equals 8 over 6, and that's giving us theta is 53.13 degrees to 2 decimal places. So that's quite simply that bit. The magnitude of F. Okay, so we've got the direction it's working in, and we've got the size as well, size in each direction, 6 along, 8 up. But what we have to do to introduce here is Newton's second law of motion equation, which is F equals ma. Now we write it like this: that this is a vector. It's got an I and a j bit. This is a vector. This is what we've got here with the acceleration. Okay, and the mass is a scalar, just a single volume. Okay, so if we look back to this triangle here, we'll just note here that if we've got 6 and 8, this effectively is like a 3, 4, 5 triangle, except it's scaled up by 2, so it's actually a 6, 8, 10 triangle. So this this length here must be 10. So if we want to, we can actually work out the vector of the force, but we just jump straight here to work out the actual scalar value of the force, which is going to be the mass times the scalar value of the acceleration. Okay, so the acceleration is 6 that way and 8 that way, meaning it's 10 in the direction of the force. So that's the scale, that's the force equals mass times acceleration, and that's just going to give us 4 newtons. Right, okay, times t seconds, the velocity of p is v meters per second, given that when t equals 0, v equals 9I minus 10. Find the velocity of p when t equals 5. Okay, so so this is a boundary condition here, so there will be some unknown constant to resolve, and that arises from integration. So this relates to non-constant acceleration, the methods that we've used in there for working out the velocity and velocity functions and the displacement functions. In this case, actually, we've got constant acceleration anyway. But in order to find the velocity, well, I mean, to be honest, we can either just use this, think of this as our Suvat equation here, or we can think of ourselves in terms of integrating the acceleration to give us the velocity. Okay, the acceleration is rate of change of velocity with time. So in other words, velocity is the integral of a with respect to t. Or we could say v equals u plus a t, just turn it into a Suvat equation. Right, so so given that we've got that, so the velocity is this is our acceleration. I write this as a column vector. That's what we've done here. The IJ form can be a little bit difficult to work with when we're doing our calculations, so I tend to represent it as a column vector. Now we've got to our boundary condition to apply when t equals 0. V equals, well, let's write that as a column vector as well, 9 minus 10. So if we substitute this value into there and this value into here, well, obviously that whole term drops out. So it just gives us a c equals 9 minus 10. So this is actually the initial velocity. Well, so it is. T equals 0, v equals this. That's the initial velocity. Okay, so that's that basically is our equation, and all we're doing now is applying t equals 5, velocity equals is the acceleration times the time plus the initial velocity. V equals u plus a t, and that works out at 39.30. So that is the vector of the velocity when t equals 5. I've left this as a column vector. I think normally I would say that if your problem is presented to you in sort of IJ form, that's how you should give the give the answer. So being true to my own advice here, really we should be writing that the velocity is equal to 39I plus 30J. And that's what we've got there. Okay, so say quite a little useful little exercise. We're dealing with angles, with forces, scalars, and also with deriving velocity from acceleration. Okay, good. I hope that's proved useful. I'll see you in the next video.